All right, here we go. We are on chapter 4, test review. And this chapter is all about force. So what do we need to know about force? You know what a force can do to an object, right? So what are the different kinds of forces that you can think of? We have gravitational force, we have electrical forces, we have magnetic forces, we have elastic forces. So remember the stuff that we went over describing what kind of forces we have. Now, gravitational force is what we call as weight. Now, what is weight? Weight is given by mass times gravity. All right, so weight is mass times gravity. So if you know the weight and if you know the mass, you can find the gravity in that place. Or if you know the weight and if you know the gravity, then you can find the mass. Or if you know the mass and the gravity, you should be able to find the weight. So this is a simple equation. Weight is mass times gravity. Force is measured always in newtons. So remember that part of it. The SI unit is newtons. The other main focus is on Newton's laws. So what we need to know about Newton's laws comes the first law. The first law talks about inertia. So what is the first law again? The first law is any object will stay in the same state of motion unless acted on by external unbalanced forces. So in Newton's law, we are talking always about balanced forces, all right? So you can have any number of forces acting on an object. So as long as the net force is zero, then the object is going to stay in the same state. Now when you say object is going to stay in the same state, the object can either be at rest or moving with a constant velocity. So this object can be at rest or some constant velocity. V can be zero or V can be constant, right? That is what will happen if you have so many forces acting, but if the net force is zero. If the net force is zero, then it can be at rest or it can be moving at a constant velocity. Okay. If the net force is zero, we also call it equilibrium. So the word equilibrium implies net force is equal to zero. Now, the other thing that is implied in Newton's first law is the term inertia. So what is inertia talking about? Inertia says inertia is a tendency of an object to stay in the same state, which means if the velocity is zero, it has a tendency to stay with that same velocity. If the velocity is constant, then it has a tendency to stay with that constant velocity. That's called inertia. And then on the second law, it says, all right, if the net force is not zero, what will happen to the object? If the net force is not zero, the object is going to accelerate. So if you have an object and the net force is not zero, it is in one direction, then it will accelerate. So the net force is equal to mass times acceleration. This is the second law. So the second law talks about acceleration of an object. When will it accelerate? When there is a net force. If you have a net force, then you're supposed to get an acceleration. So F is equal to ma. This is also a form of F is equal to ma. Instead of a, it is g. Okay. You should be familiar with all the homework questions that we've gone through in each of those parts of the chapter. All right. So in chapter 4, we did different homework exercises. You must be familiar with how to do those problems. And then coming to the third law. What is the third law focusing on? Third law focuses on pairs. All forces come in pairs. Okay, so if I push this table, then the table will push me back. That's a pair. So pairs of forces are always pairs. Okay, so if that's a book sitting on the table, the book is pushing the table down. So this is force by book on table. Now, where's a pair for that? The table pushing the book up. So it's a force by table on book. So you can see this is by table and this is by book. This is on book and this is on table. So that's how forces are paired. All right, so Newton's third law pairs. They're saying forces come in pairs, and all these Newton's third law pairs are always equal and opposite. So for every action, there is an equal and opposite reaction. That is basically what it is. Now, how does a rocket move forward? So, how does a rocket move upward? So, how does it move upward? The movement upward is produced by the exhaust gases. So it burns the gases and then it pushes it down. So the force by the rocket on the gases, it will produce a force by the gases on the rocket. Okay, so this force is a force on the gases by the rocket. What will the gases do? The gases will apply a force on the rocket which is in the upward direction. So the rocket gets a chance to be pulled up. So likewise, you can see Newton's third law being applied in different places. Now remember, the third law pairs are always equal and opposite. Okay, if I hit the table with a force, the table hits me back with the same force. So that is the concept that you need to know about third law pairs. Now, a lot of conceptual information here you should be familiar with. Coming to friction. Now, friction is a special force where it's going to be everywhere. So friction, there are two kinds. So you have solid friction and you have fluid friction. Now, solid friction depends on what factors? Solid friction depends on the surface's nature of surfaces and the normal reaction from the surface. So these are the two factors solid friction depends on. Fluid friction depends on what factors? It depends on nature of fluid. It depends on area of surface. It depends also on relative velocity, okay, of the surfaces. So it also depends on relative velocity of the surfaces. Solid friction, of course, does not depend on surface area or relative velocity. So these are the factors that solid friction and fluid friction depends on. And so conceptually, this is information. Now, solid friction comes in two types. So you have static friction, which is coefficient of static friction times a normal force. Whereas you have kinetic friction, which is mu k times a normal force. Because it depends on the nature of surfaces and also on the normal reaction. So these are the only two factors for solid. So those are the only two factors that are written here. Now, what does this equation come. What does this equation imply? This implies that you can have maximum static frictional force between two surfaces if they are at rest. And how much maximum friction can develop between two surfaces? That's mu s times normal force. So if you are having an object like that, and if this object has, if the object's weight is something, if the object weight is 1000 newtons, then there is a normal force of 1000 newtons. Okay, now if the surfaces have if the surfaces has a coefficient of static friction of, let's say, 0.5, so what happens is this one is sitting here without any frictional force, but if you apply a force in that direction trying to drag it, then frictional force will start coming into play. So initially the frictional force is not there, but when you start pulling from here, the frictional force will start developing. And how much maximum frictional force can this surface hold or provide? And that is mu s times normal force. So mu s is this 0.5 times 1000 gets you 500. So you have 500 Newton force backward. So how much force is required, minimum force required to drag it off the floor? It is 500. Okay, so understand that concept. The minimum force required to kind of move it forward is 500 newtons. Coming to kinetic friction says if an object is moving between two surfaces, there is a kinetic friction. Now, kinetic friction is not as big as static friction. It's always smaller. So the kinetic, if an object is already moving, the frictional force, the kinetic frictional force that can come into play is given by this equation. So if the mu k is 0.3 for this surface, and the normal force is 1000, that means you can expect a maximum of 0.3 times 1000, which is 300 newtons as frictional force. All right. Hope the concepts are clear so far. Okay. Now coming to other problems. Let's say, for example, you have an object of mass, let's say 100 kilograms. You have an object of mass 100 kilograms and you drag it with a force of 200 newtons. Net force. If the net force is 200 newton, what will happen is it is definitely going to accelerate. So how much acceleration can be produced? You can always use F is equal to ma to find out that. What is F is equal to ma? 200 is equal to 100a. So the acceleration is 2 meters per second square. If that's the case, after a time of 5 seconds, how far do you think this box is going to be? How much is the displacement? So how do you do this problem? To find out the displacement, you can use equations of motion. We have the acceleration, we have the time, and we know the initial velocity, 0. So if you know 3 things, you can always find out the displacement. Connecting these 3 terms, you have an equation x is equal to vit plus half at square. Substitute. X is what you want to find out. VIT is 0 because VI is 0, and then you have half times 2 times 5 squared. So if you process this, you get 25 meters. So that means this block is going to move 25 meters in a time of 5 seconds if pulled with a net force of 200 newtons. Hope that is clear. Now, how fast is it going at the end of this period of time? You can again use the equations of motion because you know the acceleration is 2. So we can find out the final velocity by using Vf is equal to Vi plus At. We can use that. Okay, so we can use this and find out information. So how fast is it going? 0 plus 2 times 5, which is 10 meters per second. So it's going at 10 meters per second at the end of the 5 seconds if you do all this. On the other hand, if you're not given the force, but instead you're given the speed at the end, for example like this, it's 100 kilograms, how much force? Not given. But if you're dragging it with this force, and if it says it starts with the initial velocity 0 and it reaches the speed of Vf is equal to 10 meters per second in a time of, let's say, 2 seconds. So you're pulling it with a force starting from rest, and in 2 seconds it reaches the speed. How can you find this force? To find this force, we need to get the acceleration first. So with these 3 pieces of data, can you find the acceleration? So to find acceleration, how do you connect these 3 things? You use this equation, Vf is equal to Vi plus At. Substitute 10 is equal to 0 plus A times 2 seconds. So therefore A comes out 5 meters per second square. Now if A is 5 meters per second square and the mass is 100 kilograms, what is the net force? So you use net force equal to mass times acceleration. So you want to find the net force. Mass is 100 kilograms. Acceleration is 5. So the answer is 500 newtons. So like that, you can actually use this net force equal to ma to get multiple problems solved. And another thing that you should be aware of is if there is a block sitting somewhere and you apply a pulling force of 100 newtons, what will happen to this block? This block is probably going to scoot on this table. With what? Horizontal force. Now, so what you do is you split this force into 2 components. So if the angle is given to you, we can find out the horizontal component by taking 100 cosine of that angle. And the vertical component is 100 sine of that angle. So you can actually find the components, the vertical and the horizontal components, by using resolving technique. So you resolve this force into 2 components and you should be able to work with that. All right, let's talk about some other problem situations. Let's say you have a mass of 50 kilograms sitting on a surface. Now, the surface obviously has some friction, and if you start applying a force here, it's not going to move. But if it says that you needed to apply 400 newtons to set it in motion, so what does it imply? If you needed 400 newton to set into motion, that means 400 newtons of friction must have come into action. So this is the maximum frictional force that came in and kept this object at rest. But the moment you apply 400, it just slips. So if it is just slipping, what is the coefficient of static friction? That is the question. So to find out this coefficient of static friction, the first thing you should do is to uh, to mark all the forces. So the force that is acting on this downward is the weight. Weight is 50 times 9.8, which is 490 newtons. And if it is 490 newtons acting downward, the normal force is also 490 newtons in this case. Okay, so the forces are 490 newtons, normal force. So if the normal force is 490 newtons, you can use the equation Fs, the maximum static friction, is equal to mu s times normal force. Now Fs is this. The maximum frictional force is 400. Mu s, you need to find that out. And Fn is 490. So if you divide by 490, you get mu s is equal to 0.82. No units for this. All right. So if, for example, all right, we determine the coefficient of static friction, but if you continue to apply that 400 Newton on that same object, if you continue to apply on the 50 kilograms, if you continue to apply the 400 Newtons, what's going to happen is, since it is in motion and the coefficient of kinetic friction is probably smaller than this, so what will happen is, as it is moving forward, the friction that's going to come in is going to be smaller. So if the coefficient of friction, kinetic friction, is 0.5, then the kinetic friction is going to be equal to coefficient of friction times normal force. Again, the normal force is 490 here, and because it's 490 downward, so the normal force is 490. So apply it, 0.5 times 490, that's going to be 245 newtons. So if you know that the force is 245 newton, that is 245 is going to be acting backward, but you are applying 400 newton forward. That obviously is a bigger force. So the net force is going to be in this direction because that's a bigger force. So according to the second law, net force is equal to ma, and the net force is 400 minus 245, and that should be equal to 50, that's a mass, times a. So it's 155 is equal to 50a, and acceleration is 3.1 meters per second square. So this is something that you should be able to understand. You apply a force to just set it in motion, then after that it is going to accelerate because the coefficient of kinetic friction is smaller, and you keep pushing with the same force, you end up accelerating the object. Okay. The other concept is, let's say if you have an object of mass 20 kilograms. So the mass is 20 kilograms, and if you push that object with a force of 200 newtons that way, if you're pushing it like that at an angle of, let's say, 30 degrees, if you push it like that at an angle of 30 degrees, what will happen to this block? It's going to slide. So what will be the acceleration with which it's going to slide? All right, so let's say if it is going to slide and the coefficient of kinetic friction is, let's say, 0.3. The coefficient of kinetic friction is 0.3. So what do you do in such a problem? The first thing you should do is you resolve this force into two components. The force has two components. One is this component, which is the adjacent component, that is 200 cosine 30. 200 times cosine 30, put it on the calculator, and you'll see it's 173.2 newtons. And 200 sine 30 is the vertical component, which will be 100 newtons. So you have 100 newtons, 200 sine 30 is 100, 200 cosine 30 is 173. So these are the two forces that are coming in. This is downward. Now, what are the other forces coming in here? This is the weight of this object. 20 kilograms times 9.8 is 196 newtons. That's the weight of the object. So there is a normal force. But how much is the normal force? You can't say the normal force is the same thing. In this case, because there is an extra thing coming here, you have to recalculate it. So what you have to do here is find out the total force acting downward. This is acting downward. This is also pushing it down. So there are two forces pushing it down. There's only one force to counterbalance it. Therefore, the downward force is 100 downward plus 196 also downward, and this is the only force upward, which is the normal force. So the normal force turns out to be 296 newtons. If the normal force is 296 newtons, because of the normal force, there is a friction coming in. So how much is the friction coming in? Friction, kinetic friction is mu k times normal force. And mu k is 0.3. So 0.3 times 296 is equal to 88.8 newtons. So this is the amount of friction that is acting on this block. And how much is the forward force? This is the forward force. So that's the forward force, and this is the backward force. So as the object is sliding forward, the forward force is 173.2 and the backward force is 88.8. And obviously the net force is forward. So the net force is equal to MA. The net force is 173.2 forward minus 88.8. That's equal to mass 20 times A. Now this is 84.4 newtons. So 88.4 is equal to 20A. So A will be 84.4 divided by 20. So that will be 4.22 meters per second square. Okay, so this is how we calculate the acceleration. Now, you should know how to work this out by resolving. Now, what will be the difference if you pull it up? If you pull it upward, then the forward component is going to be that way, but the other component is going to be, vertical component is upward. So if the vertical component is upward, then this Fn and that are going to be both upwards, and this is the only thing that's downward. So your equation is going to be 196 is going to be Fn plus whatever would be the 100 newtons. So 196 is Fn plus 100. So Fn will turn out only 96. And then that means the friction has to be calculated based on the 96. So that will be the difference if you push it or pull it. You know, when you push it, normal force increases, and that is why friction becomes bigger. When you pull it, normal force decreases, and so the friction becomes smaller. So it'll be easier to pull something rather than push it. Okay, so that's a concept that you should be familiar with, and you should be able to work through this kind of problems and that kind of problem. So then you need to go over some of the material that you've done from your exercises. So go through the exercises, the homework, especially the homework exercises that you've done. Okay, go through each and every problem. We have worked out the problems in class, and you should clearly know how the problems are solved. So go back to your homework and find out each and every question that we discussed from the textbook. All right, so with all this help, you should be in a position to do the test well. Make sure you do your work neat so I can read it, and don't forget to write your name on the test. And if it is requiring some drawings and force diagrams, You must make sure that the diagrams are neat and they are labeled with proper names like weight, normal force, and whatever. So all those things must be properly labeled. And um, yeah, so just go back through this video and try to understand all the concepts that are required to be known in this chapter, and you should be doing pretty well. All right, all the best for chapter 4 test.